Hi, everybody. I'm Bryan Norcross along with Luke Doris. This is podcast number 2 of Hurricane Season 2021 and number 58 in our series. Welcome to hurricane season. It's coming in like a lamb, more or less so far, Luke. Nothing certainly significant. We almost had that bill thing we talked about last week, but I mean, really, things look pretty calm out there right now.
Right now, yeah, we had little Anna that was harmless up in the way extreme North Atlantic, and that's it. It's quiet stuff out there now.
Right. Today, we're going to talk with Dr. Phil Klotzbach, who, of course, is famous for his work with Dr. Mike Bell at Colorado State University, putting out the seasonal hurricane forecast. As a matter of fact, they just put out one today, and we're going to talk to Phil about that and the changes since the spring and what he's thinking for this hurricane season and how this year is different from the supercharged year last year. Colorado State, of course, was the home to the amazing Dr. Bill Gray, who started seasonal hurricane forecasting in 1984, and then Phil took over the project in 2005 and worked with Bill until Bill died just about 5 years ago now. There's always a lot to talk about with Phil, and he'll be along in just a couple minutes. We're recording this podcast on Thursday, June 4th, 2021. If you're listening at some point in the future, for the latest, you've got to tune in to Channel 10 in South Florida or local10.com, where we stream all the Local 10 newscasts beginning at 4:30 in the morning, and most of the day there's a Local 10 newscast on these days. Also, of course, there's the Max Tracker Hurricane app and the Local 10 Weather Authority app for current information. And check out on local10.com/hurricane, and you can sign up for the newsletter that I write whenever there's anything active. I'll keep you up to date on what's going on in the tropics, and then you can get it emailed directly to you. So local10.com/hurricane, and then kind of scroll down a little bit and you'll see where you put in your email address, and then you'll get them whenever we publish them. So, Luke, we've had a number of online conferences and webinars with National Hurricane Center folks and National Weather Service folks this spring, all online, of course, because of the pandemic. Has anything stood out to you in terms of the stats and the plans that they've talked about for, this year and into the future?
Well, one kind of annoying and oddball stat that was drudged up, and that was this. We're in neutral conditions. We're not in La Nina. We're not in El Nino, which is tied to how active the Atlantic may be as far as tropical season goes. We're neutral. And that is oddly South Florida's most likely time to be struck by a hurricane, statistically speaking. You would think it would be a supercharged year like last year with the La Nina, but it isn't. It's what we have now, which is middle of the road neutral. Do you have any idea why that is?
Well, the thing about these neutral years is that some neutral years are just off the charts. We'll talk to Phil Klotzbach about that. And others are very quiet. So the neutral condition can have these busy years in it. So when you have the stats that includes busy years, then it really depends on where they hit. And it just turns out when we've had busy years in neutral conditions, a lot of them have hit South Florida, or an unusual number of them have. So I think, if I had to guess, I would say it's more of a random fact, that it's simply that some neutral years are very busy, and when they get very busy in South Florida in general, we have more storms, last year being an exception to that rule.
I have to wonder if that stat gets flipped to La Nina for the Gulf, because just looking at last year, 2005, the Gulf, bam, which 2005 had, I guess, a bigger spread, but last year was. I'd just be curious on that stat. I know we don't have it pulled up right now. And something else is there's a big push, or a lot of talk anyway, in the conferences, the webinars, about deterministic forecasts and how they're problematic for hurricane forecasting. On a day-to-day basis, that's what we're accustomed to. You look at the 7-day forecast, it says afternoon showers and a high of 82 degrees, very specific, the most likely scenario of whatever the computer spits out or the human forecaster pencils down. You write down a number. But that's an issue for hurricanes, and you've got to take in uncertainty, and that's where the probabilistic forecasts come in, which National Hurricane Center's done a lot of work with that, and you can see it in the surge, the winds. If we say, if we show you if there's a hurricane headed toward South Florida, and it says a 45 mile per hour wind in Miami and a 140 mile per hour wind in Delray Beach, and you see that's beyond the scope and the ability of the science. And that's within a 1 day, a 24-hour error. So it could come down to Miami, and we have that wind. So you can't do that. And there's been a lot of talk about that.
There is. Well, this comes up. I think that meteorologists have done themselves a big disservice over the last, I don't know how many years it's been now, 15 years, 20 years, something like that, where we make these deterministic 7-day forecasts on every television station, every app, everywhere you look to get a forecast. You're going to get a something that says this is what the weather is going to be 5 or 7 days from now. We didn't used to do that, by the way. I didn't do that back. It just was not accustomed to do that back in my days of doing the daily weather up through the 2000s. So this has been in the last 15 years-ish time frame that this has become the custom. Well, by doing that, we do give people the impression that we can actually make those forecasts in some kind of specific way. So that's one kind of misinterpretation of scientific reality that happens every time that anybody looks at their phone and gets a forecast, and whenever they watch TV as well. Because we just do that because that's what people are accustomed to. So that's one issue. Another issue is that we have these different kinds of forecasts that are issued. So when you see a cone, the center of the cone is where most likely the storm is going to track based on what we know. Now, it turns out that the odds of it being a little bit left or a little bit right are essentially in the noise, and you can't distinguish between that. So the line is not the best, most likely. It's a space around the line because you always have some intrinsic uncertainty on anything. So that's the kind of most likely. But when we forecast storm surge, we don't forecast most likely. We forecast the worst likely, the worst reasonable case that you're going to get. So that's again a different philosophy of forecast. So we have all these different things. You have the daily forecast where we give these deterministic numbers. Then you have the cone where we kind of make it most likely in the middle, but we give some error. And then we do storm surge where we don't make it most likely. You make it kind of reasonable worst case. And in my mind, that makes it intrinsically confusing for the public. I'm not saying that every one of those efforts isn't a good faith effort by forecasters. It absolutely is, but the poor person who's just sitting at home doesn't know anything about meteorology and has to interpret these different forecasts that have different underlying principles with them. They're all weather forecasts, one sense or the other. Anyway, you have any thought about that?
Well, yeah, I just think Laura is a perfect example of what happened earlier this year, where if you just did the deterministic forecast of, let's say, 3 feet, wherever you are, just say that's what it is. But it could be as bad as 18 if we had a little wobble. I don't know, I don't know that the spread was that much, but that's my point. In a high impact event, you have to disrupt the normal way of forecasting. And it would be irresponsible if you were to just say this is most likely and not really put out the big number, which is what would cause the death and destruction. You have to put out that. So we see a lot of that with the surge, and again, a lot of good faith effort. So, but it's difficult, man, from a TV side, just from a graphic standpoint, to try to go through all this and explain everything. There's this old quote that says, make something as simple as possible, but not simpler. And that's a really challenging thing to do while communicating all these really difficult things that you need to distill down for people to understand. But there's a lot of stuff going on, and it can be tough to break it down. Yeah,
and I think that one of our goals has to be to help people understand the information that they're being given. And that's a longer term process. All right, let's talk about the tropics just for a moment, because there really isn't much to talk about at the moment. There's this band of upper level winds coming across the Gulf, and then it dips down south of Florida because of that disturbance that was causing the rain over South Florida for a few days, and then right across the Atlantic. So nothing is going to really develop in the tropics right away, with the exception of maybe in the Caribbean because as happens early in the season and late in the season, we sometimes get this area of low pressure developing. We call it the Central American gyre, but generally it's just a large area of low pressure that spans from the Pacific up into the Caribbean and maybe the Southern Gulf, and some indication that there might be low pressure in there to watch. But nothing brewing at the moment.
Good. Man.
Yeah.
We like that.
And just one other thought after kind of an amazingly dry end of May, right? We thought that the rainy season in South Florida was going to kick in May, and then it turned into almost a drought at the end of May. It looks like the moisture's here to stay now.
Yeah, that first we got teased there for about mid-month into May, and then it just shut down, went bone dry. But what we saw finally come our way is this kind of hybrid season thing that happens as we transition into the wet season. We had a cold upper low, so you get cold temperatures aloft. Meanwhile, we get our temperatures at the ground to really heat up because we get that strong June sun just bakes the ground. So the atmosphere is wanting to flip. That's instability. Cold upstairs, about 18,000 feet, and hot at the ground, and that gives rising motion. And at the same time, we're starting to tap into that tropical moisture to our south. Our PWATs, our amount of moisture that we have in the air that it's holding, are coming up. And you feel it outside now, too. That back half of May felt great, but now it's really starting to get a pretty South Florida typical humidity coming back, and all that's a recipe for rain. So it's the rainy season from here on.
Yeah,
we're in it.
And that's why June is on average the rainiest month, because you do have still the northern effects, the colder air in the upper atmosphere, and then you have the tropical air coming in under it, and that's why it gets rainy in June. All right, let's bring in Dr. Phil Klotzbach from Colorado State University. Phil is famous for taking over from Dr. Bill Gray, who really started the science of seasonal forecasts. So here's Phil. Hi, Phil. Welcome back to our podcast, season number 4.
Thanks for having me, Brian.
So let's go over your updated predictions just out today for the 2021 season. Has anything significantly changed since what you put out in April?
Yeah, really not. They were forecasting 18 named storms. Of those 18, 4 becoming major hurricanes. We forecast 17, 8, and 4. In April, the only reason we went up to 18 was just because we had Tropical Storm Ana before the start of the season, but we're still expecting a little bit above the average hurricane season, which NOAA just changed. They now use a 1991 to 2020 average of 14 storms, 7 hurricanes, and 3 major hurricanes.
So in general, how good are June forecasts? I mean, there's still more than 2 months to go before the hurricanes really kick in, right, in any kind of big way. And things can happen, and sometimes do happen. I remember a few years ago where everything kind of flipped on us. So how often does the ocean and the atmosphere evolve in unexpected ways between now and August?
Yeah, and some years, if you look at our forecast and you look at what happened between June and August, the forecast changes very little. Other years there are big changes. You can occasionally get a sneaky El Nino that'll try to come in, or you'll think you're in neutral and it'll kind of shift over to La Nina. On average, the hurricane forecast in June is about plus or minus 2 hurricanes. So the forecast this year's for 8. On average, that means the forecast should fall between 6 and 10. There's been years where we've had big busts, the most notable bust 2013, which we could spend several podcasts talking about that year in and of itself.
Exactly, yes.
But in general, the June forecast I would characterize as moderate skill. And by the time we get to August, the skill is pretty good. That's because, especially when you get into July, the climate that you're going to have for the summer in the tropics kind of locks in. So even in May, even into June, if you look at like the shear in the tropical Atlantic, it doesn't necessarily really correlate very well with what we're going to see necessarily during the peak of the season. But July, there's just basically a lot of persistence. So if your water temperatures are warm in July, they're probably going to be warm in August, September, and October. If your shear's low in July, it's probably going to persist. And that's one of the reasons why last year we had a high forecast in June, but we went up to like what I thought was basically insane levels in August. And that's just because everything was pointing towards an extremely active season. The setup in July was extremely healthy with a very low shear. Africa was extremely active, the waves coming off Africa, and obviously the season bore itself out as being extremely active.
Now, Phil, NOAA's forecast came out a couple weeks ago, and it called for 13 to 20 named storms. That's a pretty big range, isn't it? I mean, from slightly below normal to solidly above normal. Is that indicative of a hard to pin down forecast this year, with us being El Nino, La Nina in neutral?
Yeah, and so if you look at NOAA's error bars and you look at, so with our forecast, we put out one number, which is our best estimate, but we also include kind of ranges of uncertainty. And that's based on the historical error of these models and basically fitting those to the statistical distribution. So if we basically try to replicate NOAA's methodology, so basically give you like 70% of our forecast should fall in. Our forecast of 18 storms, our range would be 15 to 21. It's about plus or minus three named storms, plus or minus 2 hurricanes. We like to just do one number just because it kind of gives the general public our best estimate. Sometimes if you get a range, I've seen a lot of times in the media, if you give a range, say we said 6 to 10 hurricanes, the media would say up to 10 hurricanes, which to the general public means 10 hurricanes. And oftentimes they'll also translate that to 10 landfalling hurricanes, which is a whole different ballgame. So, last year we had 6 landfalling hurricanes, and I think that was enough, more than enough for even the biggest meteorological person who loves hurricanes. So we try to provide basically the best estimates that we can. So we give the one number, but there is obviously uncertainty associated with those forecasts. So we predict 8 hurricanes on average. It should be somewhere between 6 and 10 if the forecast is reasonably reliable.
Yeah, you have to watch that. The producers will grab a headline and run off into a direction with it with their hair on fire. But are some hurricane seasons, I would imagine this is the case, are they just harder to predict than others, kind of like some storms are?
Yeah, I mean, they really are. And so we did a paper a couple of years ago where we looked at the 2018 hurricane season, which turned out to be a little bit above normal. And that really took a lot of us by surprise because the waters were cold, the shear was fairly high. We had a borderline El Nino. Like, it was just not it was not what you normally would expect for an active season. And from a predicting perspective, pretty much everyone was underneath what we actually got. But even if you knew exactly what the shear was like, the temperatures were like during the season, that season basically, quote unquote, overachieved. It generated more storm activity than you would expect. And so when we do a seasonal forecast, we're basically trying to forecast weather events using these large scale averages. So if the shear is low, you generally have more storms. If the waters are warm, you have more storms. But knowing exactly how those storms are going to form and where they track, you can have a year where the conditions in general are not very conducive, but you get one storm that finds this one pocket of extremely hyper conducivity, and you suddenly can get something that goes crazy. And obviously, especially I'm sure Bryan remembers very, very well in 1992 with Hurricane Andrew. I mean, late August, that was the first official named storm of the year, and it was pretty much a junk year. But that one storm found that one extremely conducive area, blew up, and we had a Cat 5 hurricane. So,
and it wasn't a very big conducive area either. It just, it was really just this narrow band of favorability there.
Yeah, correct. And you get that year after you get that year in year 2, because we do the seasonal forecast, but I watch each storm too, and you look and see very subtle things can make big differences in how intense these storms get and how long they last. And a great example of that is Dorian in 2019. It tracked over St. Lucia, and then its center reformed a little farther to the north than most of the models were predicting. Had the storm maybe traveled between the islands instead of St. Lucia, it would have been a little farther to the west, and it would have gone over Hispaniola and maybe potentially dissipated and been kind of a non-event, as opposed to being a disastrous Category 5 hurricane. So there's definitely skill with seasonal forecast, but even if you tell someone perfectly, here's what the August, September, October shear is going to look like, the water temperatures are going to look like, you can be pretty accurate most years, but there are going to be still some years that quote unquote overachieve or underachieve, and that's because again you're trying to forecast weather events on climate timescales, and there certainly can be pockets where things are more conducive or less conducive, and how these storms sometimes interact with each other too. You can get year like last year where we had Teddy, where Teddy was an enormous cyclone in the middle of the Atlantic and had this huge outflow that sheared apart both Vicky and Wilfred. So there were 2 other systems behind it that had Teddy not been there, done something, but because Teddy was there, they got wiped out. So it's those kind of things that, these forecasts have skill, but there can be things on a weather time scale that kind of can basically blow stuff out.
Yeah, so you're generally using macro things to do the forecasting, and the point is there are micro things that also affect storms significantly, which is what we try and forecast, why forecasting storms is so hard. So as you know, I'm really interested in the question of what is the normal number of named storms in a season that we should use, right? Because modern technology has been around for about 20 years or so, or even less in some cases in terms of high resolution satellites. And we've only had them like 4.5 years. So how do you create coherent enough statistics to, get a meaningful normal when technology is changing so fast, and that doesn't even take into account the changing climate? You're the statistics guy.
Yeah, and so we actually published a paper led by Carl Schreck at NCEI and NOAA, where we basically looked at this question because we knew that this was the year that normally NOAA switches everything. So they have a 30-year average that they update every 10 years. So it was 1981 to 2010 through 2019, and then through 2020 rather, and then in 2021 they shifted. And so if you look historically, you look at basically if you were to use a 30-year average ACE or accumulated cyclone energy or number of hurricanes and use that to predict the next 10 years, which is kind of what you want. You want your quote unquote normal to be representative of the next 10 years. It actually has lower skill than say a longer term average, a 50-year average. And that makes sense because the Atlantic, if you even go back to the late 19th century, you can see kind of these periods where it's much more active and then quieter and then more active and then quieter. And so 81 to 2010 was pretty representative because we had 81 to 94 that were pretty quiet in general, and then 95 to 2010, which were pretty active. And then in 2011, in 2021, obviously the 80s were generally super quiet, and the 2010s were generally pretty active. So the average went up. So we were arguing using a 50-year average and then just basically adding on 2 storms per year, which is about Chris Lancy at the Hurricane Center has done a lot of good work looking at basically the increase. So we're not necessarily observing more hurricanes, but we're observing more weak, short-lived storms. And so with some of these microwave satellites and some of these diagnostic tools that we have, we're naming more weak, short-lived storms than we used to. And on average, it's about 2, maybe as much as 3 storms per year now than we did in, say, the 80s and 90s. So we were arguing basically using a 50-year average, so 1971 to 2020, and then just adding on 2 named storms. So that would have come up with an average of 14, 6, and 3, I believe. So fairly similar to what NOAA was using, but we think in general it's more robust to use a 50-year average than a 30-year average, just given the multi-decadal cycles that the Atlantic has, where you go through pretty active periods and then pretty quiet periods. Because if, for example, you're using 61 to 1990, especially if you're using 71 to 2000 as your climate, and then you look at what happened in the 2000s, especially with 03, 04, and 05 in there, right. It would have been not done well at all. So we're arguing using a 50-year average, and then you don't necessarily get as much volatility as you get using a 30-year average.
Right, although you could also make a case if you think that, on average, the Atlantic is warm and going to continue to warm, just looking at the average numbers, and you can make a case for that. I think that there's a gradual warming in the tropical Atlantic, that maybe a shorter average is actually more representative of the next 10 years. I mean, the question is to what degree climate forcing is going to tip the scale just at least slightly, right? Yeah,
and so we actually showed that it's kind of an interesting curve, because basically the skill is better at 10 years and 50 years, and it's actually at its lowest at 30 years. And so we verify the skill of our seasonal forecasts. One of the metrics that we use is a previous 10-year average. That's actually a fairly hard, quote unquote, no skill metric, because obviously anybody can calculate how many hurricanes you got on average the last 10 years. So that's basically what we use as kind of our no skill metric. And that actually is a fairly hard one to beat. But yeah, it's interesting that actually 30 years doesn't work out well, at least for Atlantic hurricanes. And probably also for Eastern North Pacific hurricanes, because they tend to go opposite of each other. So we were arguing for the longer term, because obviously if you use 10 years, how often do you update it? And then also it can be really volatile, so it can bounce up and down. Obviously, if you pull out, say 2030, we have very few storms, and suddenly 2020 is not in your 10-year average. Your number of named storms per year could go way, way down. So it's a challenging. And so I should point out to NOAA NOAA used to use a 51 to 2000 average. And then in 2011, they shifted to a 30-year average, and that's because of the increase in short-lived named storms. They wanted to better be able to capture that, because before I think the average was like 10, and they're like, well, that's not really average because we're naming more storms. And that worked out fine because, again, 81 to 2010 was about 15 active and 15 inactive years. But obviously the last 30 years in general have been more active. The early 90s were quiet, but then since then it's been pretty amped up. And so obviously it remains to be seen if, this is kind of a permanent elevated phase, or if over time, probably what more likely is the Atlantic will go back down and the Eastern North Pacific will go back up, because the Eastern North Pacific Ocean has actually been way down with its hurricane numbers the last, say, 20 to 30 years. And that tends to be, they go opposite of each other. When the Atlantic goes up, the Eastern North Pacific goes down. And that was a classic case in point of that was last year. We ended up with 14 hurricanes in the Atlantic and I believe 3 in the Eastern North Pacific.
Right.
Wow. Well, Phil, while we're on this, what's your take on the questions about the AMO? The idea that the overall number of storms that form in the Atlantic, it goes in this natural cycle of every 25 to 40 years based on oceanographic reasons. Is it a fundamental property of the Atlantic meteorological and oceanographic system, or is what we see in the record essentially an artifact of air pollution and volcanoes? What's your sense on that in the AMO?
Yeah, I mean, so I think the 70 to 94 time period probably had an additional knockdown boost from the aerosols. But if you go back and look historically at hurricane data, even prior to 1900, the late 1800s were insanely active. Basin-wide data is pretty marginal, but we had a number of landfalling storms we had back then was extremely high. You go back to like the 1880s and 1890s, very, very active. And then if you go back to around the Civil War, it likely was pretty quiet. And then maybe the 1830s and 40s, from some of the records that we do have, probably more active. And you can kind of see multi-decadal variability if you separate out even just looking at Atlantic hurricanes, looking at some of these other proxies that we have, you can kind of see this multi-decadal cycle. And so, obviously you can have the aerosol pollution was a big deal in the 70s and 80s into the early 90s. But one of the things that one of my issues is that the Atlantic a switch flipped in 95. It went from complete junk, almost no hurricanes, to extremely active. The Atlantic got way warmer. It was almost like a step function over the course of 3 or 4 months. Whereas if it's an aerosol thing, it wasn't like suddenly they flipped a switch and said, okay, now we're not putting out pollution. Like it's been a slow, gradual decline in aerosols with the Clean Air Act. It wasn't like they flipped a switch and suddenly said you can't pollute anymore. And if you look at kind of basically the way these things have gone back with time, it's been pretty sharp flips between 1925 and 1926, between 1969 and 1970. There's been these really quick switches, which to me point more to an ocean circulation change than something driven by just aerosols and volcanoes, because it wasn't like there was a massive volcanic eruption in 1925. I shouldn't say that. There wasn't a massive volcanic eruption in 1969 to suddenly cause the Atlantic to get much cooler. Mm-hmm. But there was a phenomenon known as the Great Salinity Anomaly in the far North Atlantic, where the salt dropped considerably, and the North Atlantic got a whole lot colder. And then we went into a period of about 70 to 94 where things got the overturning circulation in the ocean got a lot weaker. You see a similar thing in the mid-1920s as well. And so a colleague and I actually published a paper about 10 years ago where we tried to kind of look at this decadal variability and multi-decadal variability. And she was from Germany, so she could read German, and some of the old German publications from the early 1900s. You could see some of these old salinity records back even as far back as 1900, where you could see kind of these big changes in salinity. So I think there's definitely a lot of evidence for natural variability in the oceanic system, in addition to obviously other things going on like volcanoes and aerosols. Not saying those don't play a role, but I think there's a natural multi-decadal signal. And if we basically say it's all just volcanoes and aerosols, I don't think that's going to pan out real well in the next 20 to 30 years, just assuming that's the only thing, because there's really nothing, I think, to keep us from saying that the next 30 years, the Atlantic's going to be constantly elevated and the Eastern North Pacific's going to be constantly quiet. I suspect at some point that's going to flip. We're going to go into a more El Nino-like basic state, as opposed to just generally we've been in more La Ninas the last 20 to 30 years, which has helped also amp up the Atlantic at the cost of the Pacific Ocean in terms of hurricanes and typhoons.
So I remember Dr. Gray talking about forecasting rainfall in Africa back in the day, right? It was in the Sahel of Africa, which is Southwest Africa, the band just south of the Sahara Desert, as a key to understanding how busy a hurricane season would be, right? The idea is that they are the the systems that generate there become the seeds that eventually turn into tropical storms and hurricanes on occasion. And if you throw out more seeds, you get more storms. So that was the fundamental idea. At least that was the idea at the time. So how do you think about that today? I noticed in your, for some years now, I think, you haven't made that part of your calculations on how busy the season would be, but I can remember that so clearly from Dr. Gray's original thinking.
Yeah, so we don't. So with our seasonal forecast now, we don't explicitly look at precipitation over Africa as a predictor going into our model. But what I do look at is I look at the upper level circulation over Africa, and that's actually a very important predictor. So in that, basically, if you get anomalous upper level easterly flow, that tends to mean a more vigorous West African monsoon season. So we don't look at the precipitation because there's definitely just issues with the precipitation data coming out of Africa and its consistency in time. But we look at upper level winds over West Africa
as a proxy, essentially.
It's effectively as a proxy, and that actually works out pretty well as one of our predictors. So so we look at it in two ways. So with our August forecast, we actually just look at what it was in July, and then with our earlier forecast, we use climate models to forecast what those conditions, upper level wind conditions, are going to look like over Africa during July. And the models actually do a surprisingly good job. A model can't say, July 6th, the winds are going to be, 2 meters a second stronger than normal. But what they can do is over a monthly average give you a reasonably good idea. And especially the Met Office model does what I thought was a surprisingly good job getting correlations like 0.7 from March. So we do still look at Africa, just not using precipitation, more of the upper level wind features. And those generally are just more reliable from these historical data sets that we get than the precipitation itself. But yeah, Dr. Gray was a huge proponent of Africa. And it was, his idea was on average, and I think this even goes back to some of the stuff that Neil Frank did way back in the day, where, the overall number of waves of these systems coming out of Africa, these African easterly waves, these thunderstorm complexes, is fairly constant. But it's the vigor, like how organized they are and how vigorous they are. And so like last year, it was these waves coming off Africa were extremely potent. And to me, the thing that was one of the most impressive things about last year was both Eta and Iota, so two storms that formed in November, came from African easterly waves.
Right.
That's insane.
It wasn't supposed to happen that way, yes.
Yeah, you don't normally get, a major hurricane from an easterly wave in mid-November. And so that to me was last year's wave season was extremely vigorous. And one of the reasons why, especially with our August forecast, we basically said, let's forecast as much storm activity as we can, because basically everything was pointing towards it. And last year didn't quite, so we had extremely active season, didn't quite play out the way I thought it would. I would have thought we would have gotten more stuff right off of Africa. We had some stuff right off Africa, but it was more in the Western Atlantic,
right,
which is obviously extremely problematic because if stuff forms in the Western Atlantic and intensifies, it's really got no place to go where it can't do damage. And obviously we saw that last year.
Right.
Phil, you mentioned something in your forecast, and you would expect this, the sea surface temperatures. And, along the main belt that we look at, the main development region, the Atlantic is near, maybe even a little bit below average temperature-wise, but the subtropical Atlantic, the waters north of there, are warm, and they've been consistently very warm. How does that factor into your forecast? And do we know why the subtropical Atlantic just seems to be so persistently warm?
Yeah, so we use this. So in the peak of the hurricane season, obviously it matters most what's going on in the deep tropics. So between like 10 and 20 degrees north, where most of the systems come off of Africa, they move into, if the waters are warmer, that's more fuel for the hurricane. It also tends to be associated with lower pressure and a more unstable atmosphere. So basically just juicy conditions for these systems coming off Africa. Preseason, so April, May, even into June, the correlations are actually higher between hurricane activity and water temperatures in the subtropical Atlantic. And that's because when the subtropical Atlantic is warm, that tends to force a lower pressures and a weaker subtropical high pressure system, especially in the eastern Atlantic. And so if you have a weaker subtropical high, around that circulation around that subtropical high, you have your trade winds that blow out of the east. And when the waters are warm and the pressure is low, those winds are weaker. And kind of like if you get out of a swimming pool on a windy day versus a calm day, if it's a windy day, you get cold really quickly. There's a lot of evaporation, a lot of churning up of the ocean surface. So if you have strong winds blowing across the tropical Atlantic, that can really knock down the water temperatures. Whereas if the waters in the subtropical Atlantic are warm, it tends to force lower pressure, weaker winds blowing across the tropical Atlantic that tends to feed into a warmer tropical Atlantic. So right now we're anticipating that over the next couple of months we will see, obviously the tropical Atlantic warms up every year from spring to summer, but we anticipate that warming to be occurring at a faster than normal rate.
That's interesting. I was expecting it to be tied to a flurry of the early season storms, up in the North Atlantic, tied to, the subtropical systems kind of padding the stats, but it's more related to shear. So interesting.
Yeah, and and so when the Western Atlantic, there can be some relationship with the storms, with getting some early season storm formations, but those typically don't relate real strongly to these kind of integrated metrics. So the forecast, the index that I like to forecast, that we forecast at CSU and that NOAA forecasts and puts a lot of emphasis on, is this accumulated cyclone energy, which is an integrated metric that accounts for frequency, intensity, and duration of storms. And so, a storm like Ana that was out there for a couple of days is a weak storm, generates very little ACE, whereas long-lived major hurricanes, so like a Hurricane Dorian, most classic recent example being Hurricane Irma, generates a tremendous amount of ACE because they're long-lived major hurricanes. So these systems that form in the Western Atlantic and are around for a couple of days, they might give you a named storm, but they're not going to generate much of this ACE. So last year we had 30 storms, which was the most we'd ever observed in a season, but the ACE was well above normal, but not as high as you would expect for 30 storms. And that's because most of the storms last year formed in the Western Atlantic. So we certainly had frequency last year, and we certainly had intensity, but we just didn't have a duration of storms like we've seen in some other years. And so that's why we forecast ACE, and we forecast all these different metrics. So we forecast the number of storms and the number of days, how long they're going to last, and then forecast ACE. And so looking at our forecast, you can see like some of the values we almost got right on the number, and others we were off, and that's just because every season is going to break down differently. Some years you get, like 2004, we had 15 storms. We had an ACE that was much higher than last year. That had 30 storms, but we just had very long-lived major hurricanes in 04, most notably Ivan and Francis and Jean, very long-lived major hurricanes. When you can have another year like 2005 where the ACE was similar to 04, but it did almost twice as many storms because more of the storms formed in the Western Atlantic and had shorter lifetimes. So ACE is the primary metric that we target, and then we basically say, okay, if we forecast this ACE value, how does that normally break down in terms of the number of storms and hurricanes? If you have an ACE of 150% of normal, how does that typically break down in terms of named storms, hurricanes, and major hurricanes?
Okay, so back to El Nino and La Nina. We had a La Nina last year, which colder water than normal in the eastern tropical Pacific, and that contributed to the super busy year. A neutral condition is forecast this year. What do the stats say about neutral years?
Yeah, unfortunately, the stats of neutral years is pretty much anything goes. I mean, you have some of the most active seasons on record, like 2005 was a neutral year. Alternatively, you have some real duds of seasons like 2013, which had 2 hurricanes, and they both happened in one weekend. So if you're on vacation that weekend, you missed all the hurricanes we got in the one year. So when you have a neutral conditions, then you really start to focus more on what's going on in the Atlantic. So that in the Atlantic tends to be somewhat more important. I think at this point, my best estimate would be we'd probably be cool neutral, so a little bit colder than normal. The chances of getting an El Nino now are pretty low. Overall, the kind of the low-level wind forcing across the Pacific looks to be fairly healthy to keep things from getting much warmer. The trade winds just east of the international date line were very strong in May, so basically we weren't able to get a lot of anomalous warmth or warming faster than normal in the tropical Pacific, kind of held things at bay. So I think we're probably locked into neutral. There's a chance maybe we'll go back to La Nina, but that's probably a higher chance in the fall, maybe later in the fall, that we might have a double dip La Nina, where we had La Nina last year and potentially a second La Nina this winter. There's some potential indications for that, but I think NOAA's latest outlook only gave like an 8% chance of El Nino for August through October, which is extremely low. And NOAA's been very consistent at saying the chances of El Nino for this hurricane season are very low. Now, if we're talking about next year's hurricane season, I think the odds of El Nino are probably fairly high, but we have plenty of time to talk about that later.
Yeah, just the odds. You're saying just based on the odds after you have 2 El Nino or La Ninas like this, usually it goes back the other way. And we are seeing some subsurface warming and so forth. Yeah,
and also too, like we haven't had a healthy El Nino since 2015, so usually every 8 to 10 years or so, you need to discharge all that heat, and that would be about the time. But obviously, we have plenty of time to speculate on that. We'll see if I'm wrong, and the 8% chance that NOAA gives becomes the 100% chance by August through October. But I think at this point, it looks fairly unlikely.
Yeah. Phil, you're also predicting the odds this year of a hurricane coming within 50 miles of the coast, essentially a hurricane hit in counties, states, the East Coast, Caribbean countries. You've done that before, but this seems new and more detailed. What's different this year?
Yeah, so this year we've done a little bit different approach. So we're using the Hurricane Tracks tool from NOAA. It's coast.noaa.gov, their Hurricane Tracks tool. Mm-hmm. And so what we did is we basically counted all the storms, hurricanes and major hurricanes that track within 50 miles of each county and parish in the U.S. along the coast, as well as each state that's along the coast, as well as Caribbean islands, Central American countries, and then the Atlantic provinces of Canada. And what we did is we used a 50-mile buffer because we want to obviously include storms that may not have made officially landfall in your county, but still brought significant impacts. And it also allows storms to be tabulated that may have gone well inland, say like Isaias last year that was a tropical storm well inland after landfall. So what we've done is basically calculated the number of storms for each county. And then what we do is we convert that into a probability. So basically your climatological, your long-term average. And then we simply just adjust those probabilities based on the idea that more active hurricane seasons have more landfalls. You can obviously have a dud season with one significant landfall, like 83 with Alicia or 92 with Andrew. But in general, more active seasons, aka 2020, are going to have more landfalling hurricanes. And if you look at, say, the 10 most active seasons since 1950, and look at the number of major hurricanes in those, there were 15. And in the 10 quietest years since 1950, there was only one major hurricane landfall. So certainly, while you can obviously have good strings of luck or bad strings of luck, in general, more active seasons do have more landfall. So this year, the probabilities are somewhat elevated because we are predicting a little bit above normal hurricane season.
Phil, let's talk about what happened last year in the tropics. From a broad standpoint, why was 2020 so active? Have we uncovered all the major factors that brought us just a barrage of storms last year?
Yeah, so last year was extremely active. But if we had done a podcast at the end of September, I would say we had a tremendous amount of quantity. We had only had 2 major hurricanes at the end of September, which is just a little bit above normal. And the accumulated cyclone energy was just a little bit above normal too. And what stood out to me was the last 2 months of the hurricane season, October and November. It was really pretty almost cartoonish in terms of how much storm activity we had and how strong these storms were. The National Hurricane Center actually goes through after each year and reanalyzes the hurricanes. And so when they did their reanalysis and basically looked and took in additional data, they upgraded Gamma to a hurricane and Zeta to a major hurricane. So we ended up with 5 major hurricane formations in October and November. The most in any previous October, November was 2. So it was extremely actively. That was likely fueled by both the moderate La Nina event, keeping shear extremely low, even well into November, as well as we had very, very warm waters in the Caribbean, basically just fueling these strong storms, one right after the other. I remember looking at sea surface temperatures in around October 1st and texting with Eric Blake at the Hurricane Center, and we had this large area of 31 degrees C plus or 88 plus Fahrenheit water, basically just rocket fuel for hurricanes. And if you can just get something into that, and we saw, Gamma underwent rapid intensification before it hit, then Delta, then Zeta. I mean, just like one right after the other. And especially those last 2 were really just, kind of the just Eta and Iota in the Caribbean, just one right after, basically just one storm formed, did its thing, and the next storm came right after it. And it was almost the exact same thing, like extremely low shear, ridiculously warm water, just like a perfect environment for a hurricane. And both of them obviously took maximum advantage of that.
Yeah, and generally low pressure down there just kind of sat there, and the atmospheric conditions were right. But, I remember back in 2005, and it seemed like any system that thought about spinning up turned into a storm, right? And it almost felt like there had to be something different in the atmosphere besides the normal macro things, besides just the shear, the upper level winds, the water temperature. It felt like, there was something lifting the air in the atmosphere, like the whole atmosphere was under a MJO kind of, favorability. Do you think there's some other factor in these super busy seasons that just makes storms, develop, or is it just really the macro stuff, or we just don't know?
Yeah, I mean, I think there's a combination of factors. So, I mean, to get, an insane number of storms, you need to have storms forming everywhere, because basically you can only get so many storms forming off Africa. If you get a really intense hurricane like a Teddy, it'll create a big outflow and shear off other storms. And we saw that in 2010, where we had, a super conducive environment. We had a really healthy La Nina, super warm water in the Atlantic, and we ended up with 19 storms. But basically one wave would form and then it would intensify and it would basically shear off the wave behind it. So you almost need to get storms forming everywhere. And that's, I think, what we saw last year was just, you get one storm in the main development region, one storm in the Caribbean, maybe one storm in the Gulf of Mexico, and then one storm kind of out in the middle of nowhere. And so that's basically, you kind of, to get an optimal number of storms, you have to get formations in all parts of the basin. And certainly we saw that last year, because obviously, even if you look at the end of the season last year, we had 7 storms in October, November. I believe 2005 had 10. So 2005 had more storms. But what really stood out about last year was basically every storm that formed late in the season basically ramped up and just went max go as soon as it formed. And that's really what stood out. Because earlier in the season, we had a ton of storms, but a lot of them were kind of in these marginal environments. So they would form and then they just kind of fizzle. We had a lot of quantity, but not as much quality. And late in the season, when we got our really intense, basically a really intense, high intensity and high impact hurricanes. A lot of those were the ones we got late in the season.
Right. Going back to the whole question of what's normal, but thinking about that in a different way. Here in South Florida, I talk a lot these days about kind of the misperception that people have that, boy, hurricanes are hitting like crazy here now. Even taking Andrew into account, for people that are alive today and lived through the 70s, 80s, and, up to today, the last 50 years, it feels like at some level that, boy, we're just getting hit right and left with them now, and we didn't used to, right? But, as the stats guy, you touched on this earlier, but normal for South Florida is a whole different scale of hurricane hits, right? How would you describe what normal, if we go back to normal, like the first part of the 20th century, the first half of the 20th century in South Florida, people would think the world was coming to an end.
Yeah, and I mean, obviously you and I have talked about this a lot before, but one of the best kept secrets is what happened in South Florida in the late 40s. We had 5 Category 4 or 5 5 Category 4 hurricanes hit South Florida in 6 years. And obviously, like you said, if that were to happen again, that would be like you said, it would seem like the world was coming to an end. And so, obviously we can talk about climate change and its impacts on hurricanes, but one thing I always tell people, with climate change is, hurricanes may get worse, but we need to look at our history books and know what's happened in the past. And obviously in the 40s, the population of South Florida was much less than what it is now.
Drastically.
So, Phil, I'm sorry, I didn't mean to cut you off.
Go ahead, Luke.
Okay. When you look at, I'm thinking about, since we're on the subject of older storms, if you go back to NOAA's HURRDAT 2, the database, it gives stats on seasons from the past and every individual tropical storm and hurricane that we know about. And we know that the errors in the data have to be much greater as you go back in time. I'm thinking of like 1887, where there were 19 storms that we knew of, that just unbelievable. And that's all that we know of. There were probably more. What can we say about how accurate the records actually are?
Yeah, and so, even with this paper on 2020, one of the things that we're doing is we're writing a sidebar kind of talking about hurricane data accuracy going back in time. And we talked already about since 2000, with these microwave satellites and some of these new techniques, adding some weak short-lived storms. As you go back further in time, the data does get less certain. And so we wrote a paper, last year on the 1933 hurricane season, which was basically what I would say is 2005 before 2005, and they observed 20 storms. And one of the reviewers asked, could it be possible that we actually had 28 or more storms that year? And we really don't know. We only know, basically, if you look at the tracks from if you look at a track book of Atlantic hurricane activity and just flip back through, it looks like we have fewer and fewer storms in the Eastern Atlantic. And that's not to say we did, it's just that we had no way to observe them. We didn't have satellites prior to the mid-60s, prior to the 40s, we weren't flying planes in the storms. So, we just missed storms. And the hurricane data set is great, but in general, there's greater uncertainty as you go back in time, but also there is likely an underestimate of storm intensity. And so we did this with 1933, if you take the accumulated cyclone energy that was actually generated that year and actually just apply the bias rote to all the storms, I mean, you can get an ACE that's, puts 2005 to shame. And as you mentioned, you have like 1886, you have 1926, some of these other years that were extremely active. But we can compare them in terms of things like landfalls, were probably pretty accurate. So those are probably reasonable. But in terms of, these storms that are listed as category 4s, could they have been a category 5? Sure. In general, we likely underestimated them. And if you go back in time also and look at even intensity changes in storms, they're just smoother because we observe these storms less often. So, now we fly planes into storms almost constantly when they're near land. So we know the storm intensified by 10 knots or the pressure fell by 10 millibars. We know it did it. Whereas before they may have been flying one plane a day or not flying any planes into the storm. So, a ship might happen to encounter it. And so you can say, okay, we think it was 80 knots for this day. It's 120 knots, 2 days later, but we don't know exactly how it got there. If it intensified quickly or it took a while. So
or if something happened in between.
Going back in time.
Yeah, if something happened in between. So sometimes you know what it is here and you know what it is there, but you don't know what happened in between, right? And now we know those things. That's
correct. Yeah. So there's a lot of interpolation and stuff that goes on if you look back in time. So there's definitely caveats when you go and look at these historical storms. And so, when we did this paper on 1933, we tried to call out some of those issues. And even when we're comparing 2020, the latter part of the season, we're trying to call out some of the, when you're comparing it against historical seasons, you're not comparing apples and apples, you're comparing apples and oranges. And so some things are more reliable, like landfall data is probably pretty good back to 1900, given most of the coastline was fairly populated enough that you wouldn't have missed a hurricane. Once you get back into the late 19th century, especially in places like South Florida, the Florida Panhandle, parts of the Gulf Coast, you may have underestimated storm intensity just because there were very few, there weren't many people living there. So, especially as you go basin-wide, since the mid-60s, it's probably reasonably reliable, but there probably are some, certainly for named storms, there's definitely storms that we name now that we didn't name in the 60s and 70s, and I know they're Hurricane Center is going to go back and reanalyze all those years, so there may be some increases in short-lived storms. But unfortunately, we can't go back and put up a satellite in 1886 to know what actually really happened that year. So we know it was crazy active, but we can't really 100% quantify how that compares with 2020 or 2005 or any of these other recent really active seasons.
Yeah, 1886, 1893. I mean, insane. Even in the Northeast, crazy. Clearly, forecasts for hurricanes are getting better, especially track forecasts. They've dramatically improved, really, because of computer power, and that allows higher resolution models today than it used to. But it seems like the average error has kind of leveled off, especially in the couple of days before landfall. Farther out, it's still getting better. But is your sense that there's some fundamental rule of nature in play and that we're approaching or going to approach a limit on how well we can forecast a hurricane, where it's going?
Yeah, and Chris Lancy at the Hurricane Center actually published kind of a provocative piece kind of arguing for that at, maybe at longer ranges we can still keep getting better. And those forecasts, you look year after year, the track forecasts are getting better. But arguing that maybe 1 to 2 days we're starting to kind of reach that limit of predictability just because there is this basically kind of noise in the system that we can't, these hurricanes wobble and there's little things that we might not be able to actually forecast no matter how much computational power we have. But one thing, the AMS, the American Meteorological Society, we had a tropical meteorology conference a couple weeks ago, and Mike Brennan at the Hurricane Center showed an interesting plot where he actually showed significant improvements actually even in the intensity forecast, which I thought was really heartening because, before that talk, if I got in the podcast, I would have said, the track forecasts are getting better and better and better, but the intensity forecasts, they're getting better, but only incrementally, but they actually are starting to show some significant signs of improvement there. Well,
especially if you take the rapid intensifiers out, right? Which you can't do as a practical matter. But if you don't worry about that problem, if you make that a separate problem, then the intensity forecasts are actually significantly better.
Yeah, and you are getting some improvement even at being able to forecast rapid intensification, which is defined to usually be 35 miles an hour or more in a 24-hour period. And especially you look last year, the Hurricane Center late in the season got extremely aggressive at forecasting intensification, yes, which bore itself out really, really well. Mm-hmm. But I mean, they were forecasting intensification rates that normally probably 20 years ago they wouldn't have necessarily forecasted. But
I don't think they would have done that 5 years ago. I mean, actually, they were really aggressive. But, also they had just seen one do it last week, so forecasting it again this week wasn't quite so big a leap.
I mean, but it was impressive to watch.
Yeah,
and
it was.
I think
it really was.
There is some improvement with some of the regional models to being able to forecast some of these rapid intensification events. But rapid intensification is tricky because it's a function of both the environment, so what the shear looks like, the water temperatures, the moisture, but it's also a function of the structure of the storm itself. And there's certainly been times where you see a storm and you look at the environment and you say, this storm should blow up, it should go, and it doesn't, and then bam, it goes. And I remember with Hurricane Iota, they basically, it was like, the system formed and it was like all systems should be go, and it was about a day and it just kind of dinked around, and then suddenly it was like the bottom fell out, and it was just It was a combination. I think there was a little more shear than the models were forecasting, but also it may have just been the structure of the storm wasn't quite well developed enough yet to really take advantage of the conducive environment. And then once the structure got ready, then it was just bombs away and it just blew up and extremely rapidly intensified.
Well, on a related subject of hurricane forecasting, there's been a discussion for a number of years about the National Hurricane Center forecast being extended out to 7 days. Putting out a forecast that says that there's no threat, for example, would make it seem like it'd be difficult to warn people if that forecast were to change. What are your thoughts about that?
Yeah, and so they've been looking at extending forecasts for tropical weather outlooks as well as forecasting track and intensity. I'm not sure exactly. I know it's not this year. I'm not sure if it's potentially going to be next year or when they're going to actually potentially implement it. But, trying to also extend these tropical weather outlooks. So right now the Hurricane Center goes out to 5 days and looks and sees, is there anything that potentially could form in the next 5 days? And they're potentially going to extend that out even a little further. And so, it's a tricky thing. I mean, there certainly have been cases, and I can talk from personal experience with Isaias last year. My mom was going on vacation about 7 days before Isaias formed, and she said, do I need to do anything with my shutters, hurricane shutters? And I said, no, you're fine. And she had to get the neighbor to put up the shutters because we got something that formed that the models weren't really showing. Everything was kind of looked pretty anemic. And so it is a tricky problem. Obviously, even 5 days out, there can be times where things look quiet, and then the next day stuff really starts to ramp up. But, the model guidance is getting a little bit better for Genesis. Genesis itself is a really hard problem, trying to forecast. Once a storm's out there, it's not easy, but it's, I guess, a little more straightforward than forecasting Genesis. And you'll see these systems that look really favorable. They look like they're going to go, and they just don't. And there's others that kind of look marginal, and they blow up. And Dr. Gray did all sorts of work in the 60s and 70s looking at developing storms versus non-developing storms and trying to figure out why some storms form and some storms don't. And 40, 50 years later, people are still working on that problem. It's not simple and straightforward. There's a lot that's out there, but there is reasonable guidance from a lot of these global models that can kind of help look at what's may happen in the next 5 to 7 days. And then you also have you can look and see what the environment looks like. I think Bryan mentioned earlier the Madden-Julian oscillation, which is basically equatorially propagating deep thunderstorm activity that goes around the globe about every 40 to 50 days. And sometimes when it propagates around, especially during closer to the peak of the season, it can really help ramp storms up. And so you can look at those kinds of things. And so we at CSU also we do 2-week forecasts every 2 weeks. We will try to look and see how much accumulated cyclone energy the Atlantic might generate in the next 2 weeks. And we use both storms that are out there, which is kind of quote unquote money in the bank, but then looking and seeing, is the environment conducive for Genesis? And I can talk from experience last year at the end of September. So the Atlantic was crazy. The last 10 days of September, the Atlantic got really, really quiet. And we put out a forecast, I think like October 2nd. I was agonizing over it because it looked like the Caribbean should go, but the models were having all sorts of issues with Gamma and then what ended up becoming Delta. And so it was really agonizing over it. And then Gamma formed and Delta formed, and it was like bombs away for the next few weeks. And it turned out that it was a couple of days later, it would have been a shoot and fish in the barrel forecast. But the day I put it out, it was an agonizing forecast. And my wife can attest, I was spending way too many hours looking at the models and looking at the large scale and trying to figure stuff out. So sometimes things aren't as straightforward as sometimes things seem more straightforward a couple of days later than they did when you're actually putting out the forecast. So there's definitely the Genesis, I think, is becoming better, but that's still an extremely challenging problem. So that's the area I'm also very interested in, is trying to be able to determine, is the environment going to be supportive of Genesis? And there's model guidance that can help, but there's also some of the stuff is just harder to predict, just depending on the particular storm.
This idea of making longer range forecasts, whether you're talking about the tropical weather outlook, where you're talking about what might develop over the next 5 or 7 days or something, or you're actually trying to forecast a storm. It seems to me that one of the challenges is that the system we have now is every time that we make a forecast, we make it for the next 5 days. I mean, unless the storm's going to run into land or something like that, right? And whenever they make a projection of what's going to develop, it's always for the next 5 days. Where the problem is that the implication is that if it's not there, then that implies that there's not a threat of it, I think, right? Where if you could change people's philosophy to, okay, they're going to tell us what they know, and the negative or not true. If they don't tell us, that doesn't mean it can't happen. If you could get that baked into it somehow, it's sort of like the idea that I'm not in the cone, so I must be okay. We know that that's not necessarily the case, right? To me, that's the challenge. Is that is almost the negative. Is if people feel like they're not threatened, like Luke said a moment ago, if they feel like they're not threatened already, and you do something in the overall system to let them know that they're not threatened or make them feel that way, getting them to feel threatened at a later time feels like hype. Where if they feel like they're threatened and then they are not threatened, then it just doesn't feel as bad, right?
Yeah.
So I think that's a fundamental issue with long-range forecasts.
Yeah, I mean, it's hard too, because I think also, these forecasts are getting better, so people, I think, put more stock in them than they used to. And so if you see it, if you go to the Hurricane Center and say, okay, no tropical just cyclone formations in the next 5 days, you figure, I can tune out for 5 days and check back 5 days later. And, in general, if they say nothing in the next 5 days, it probably isn't going to be anything, at least in the next 2 to 3 days. But stuff sometimes creeps in pretty quickly. And, even last month we saw with that Gulf of Mexico system, it didn't end up forming, but it got fairly close.
It was that close. It was really,
it was close. Yeah. And I mean, it was something that was almost it was on nothing, I think, 2 days before, even one day before. Right. I mean, it didn't actually form, but these things can be kind of sneaky, especially stuff in the Gulf of Mexico can kind of come out of nowhere. And the models are flaky, because sometimes, like, every model will show something forming and it'll go. And there's others where the storm will be just as strong and the models just for whatever reason don't like it, but it will form anyway. So there's definitely challenges with the Genesis predictions, but that's something, obviously there's a lot of work being done on it, but it's certainly, I think Genesis is always going to be a tricky problem, because it's these kind of marginal systems, and what kind of, some of these storms are kind of like right on the edge, and one thing can kind of push it one way or the other. Right. And then sometimes if you get the system to go, once you get the circulation there, then it can really ramp up. But there's a lot of times where just, if you get something in there just to put a little more shear on it, it'll shear it apart, and then it's just done, and it never does end up developing.
Yeah, but I think that problem of people having a sense that there is no threat is just exacerbated if you go to 7 days, for example, right? Because obviously it's just going to happen more often that things form within the window. And so saying no tropical development is expected over the next 7 days is just so much more often going to be wrong, is the point.
Yeah, I know they've been testing stuff in-house. I don't know exactly how many years, but I think for a couple of years now. So I'd be curious to see. They keep pretty good stats on that stuff, so I'd be curious to see how many times they put up nothing in the next 7 days that you actually got something, in the next 7 days. And, if you say nothing in the next 7 days and you get something on day 6 or 7, that's probably not so bad. It's just if you say nothing in the next 7 days and you get something 2 days later, that's probably more problematic, because probably if you see something that says nothing for the next week, you can probably check back in 4 or 5 days, because most people know, stuff changes. But if I see something in the next 7 days, I'm probably not going to check the next 6 hourly advisory.
Or if you say 20% in the next 7 days, people do write that off as well. It's sort of like 20% chance of rain. They just write it off, right? So let me just ask you one other thing, Phil, and because I really want to ask everybody this year this sort of philosophical / rhetorical question, and that is, since track forecasts are kind of leveling off in terms of their ability to get a lot better, they're not going to get a lot better, maybe incrementally better. The question is, do we need more science applied to this problem to solve the problem of alerting people in the public to danger and getting people to take action? Is the answer in science? Or is it like the climate question where we know enough about the dangers of global warming that we don't really need more science to be able to make policy to mitigate what we know, right? So I just think it's an interesting philosophical question of where is the solution? Is it in science now, in terms of people's safety from hurricanes, or is it elsewhere?
I mean, I think it's it was interesting. So
because you're a scientist, I know that might cover your thoughts a little bit. But
there's it's interesting. The last World Meteorological Organization International Workshop on Tropical Cyclones, which brings together forecasters and researchers from all over the world. It was something Bill Gray was really passionate about. He was the guy who ran the first one back in the 80s. They asked the forecasters, what was the most important thing? And it was improving track intensity, all the stuff. And they emphasized the warning system. So basically improving the dissemination of the warning. So, you can have a spot on forecast, and if people don't act the way that we want them to, then it's useless effectively. And so, there's still certainly room. There's a lot of scientific grounds for improvement. Certainly on the seasonal time scale, there's certainly years where we bust that we need to learn more about those. There's certainly room on the subseasonal and genesis forecasts of storms, as well as obviously is still on the track and especially the intensity forecasts. But I think I know they're putting a lot of effort into it, but a lot more work done on the social science and trying to get people motivated to do the mitigation actions that you're looking for, and basically if you want people to, if you're looking for people to evacuate, to get them to evacuate, but then not having all these shadow evacuations where all these people leave that don't necessarily need to. And I can talk for my brother with Hurricane Irma. He had to go to New York because his wife was having surgery, and they could not find a hotel room until Florence, South Carolina. And Irma was a nasty storm, and I think obviously because Irma had done so much damage all along its route across the Atlantic that everyone in basically the entire state of Florida decided to evacuate. We want people to evacuate because the idea is kind of, you hide from the wind, because generally if you're in a well-built house, the wind, your house should be able to withstand the wind, but it's the storm surge that's what you need to evacuate from. So I think trying to kind of improve those messaging things, and the Hurricane Center, I know does these kind of key statements, I think is what they call them each time when there's a storm approaching, here's the biggest things you need to be worrying about. But I think also too, putting more of the emphasis on the emergency managers, your local emergency management, because those are the people that know your area the best, and those are the people that are going to be able to tell you, they know the surge zone needs to leave versus you can stay, and all that different they know more of the nuances of your local area. And so I think, I think there's obviously still need for physical science, but I think social science is going to be a huge factor going forward, both from communicating individual hurricane risks all the way up to the seasonal timescale, better communicating what we know, what we don't know, what people should take away from this. Are these things worth anything, or should you just be using this, as an informational tool? And so trying to help basically kind of convey better what we know from a scientific perspective to the general public, I think is where a lot of work is going to be spent in the next 10 to 20 years. And I know the Hurricane Center, even if you look at products they have now versus the products they had 10 years ago, has really improved a lot of their messaging products. Yeah,
the Hurricane Center is working hard on different ways to communicate, better ways to communicate. But I agree with you. I think the answer for the future lies in emergency management and having emergency management communications, the art of communications, part of emergency management. That's really the solution. Phil, it's always a pleasure to have you. And we'll see. We talk at the beginning of the hurricane season, and it's always interesting, and I appreciate your time. Thanks so much.
Yeah, thanks so much. Great talking with both of you.
I always love talking to Phil about hurricanes. He's a fountain of knowledge. So what do you think, Luke? Do we put too much emphasis on seasonal forecasts?
Well, we don't. I don't think most do. I think, what do you ultimately do with that information as an individual? I mean, you prepare every year. Like Phil always says it. He puts it in every one of his forecasts. It only takes one, and I think a lot of people understand that. But too much emphasis, no. But it does satisfy a general curiosity, and I also appreciate how it pushes the boundaries of science as we know it. It draws a lot of attention to the hurricane problem, and it gives us an insight to just how active a season may be. I think that's worthy information, but I don't think it's relied upon too heavily. I don't think people really take action generally until they see it bearing down on them.
Yeah, but I think all the discussion is good. It is time for people that live in the hurricane zone to be thinking about hurricanes. And, what do most people ask you about this time of year? They ask you about the seasonal forecast, right? If somebody recognizes you, if your neighbor asks you, don't they say, well, so how's this season going to be? How many times have I been asked that so far this year? I mean, I don't know. Dozens and dozens and dozens.
I'm sure you get asked more than I do, but mine's usually, are we going to get hit by a hurricane? It's much more specific.
Yeah, right.
If I could tell you that, I'd be a millionaire.
Yeah, exactly. All right, Luke, thanks very much. Our next podcast is going to be with Dr. Amy Clement from the University of Miami's Rosenstiel School of Marine and Atmospheric Science, Erasmus, we call it. Amy has written some seminal papers about El Nino and can answer questions about the cycles of hurricane activity in the Atlantic, global warming, and Miami's readiness for higher sea level in a changing climate. So that's Dr. Amy Clement. Will be coming up on the podcast, and that'll be later this month. Be sure you subscribe to our podcast on your Apple or Android apps so you get notified when the new podcast is ready, or watch on Facebook or Twitter, and of course we'll let you know when a new podcast comes along. So until then, for Luke Doris, I'm Bryan Norcross. Stay safe, be well, get vaccinated, and we'll see you here next week.